Hello everyone, welcome you all to my YouTube channel. I am Shayani Chatterjee and I am back again with a new civil engineering video. For more civil engineering related videos, please search in YouTube Shayani Chatterjee and you will get a wide variety of civil engineering videos in my channel. So if you are new to my YouTube channel, please don't forget to subscribe to my channel and press the bell icon for instant updates. In this video, we are going to study about U-tube manometers. So first of all, let us see what is a U-tube manometer. This type of manometer is U-shaped and that is why the name is U-tube manometer with one end open to the atmosphere. So here you can see this end is open to the atmosphere. It is used for measuring suction. It has the capability of measuring both positive pressure, that is the gauge pressure, and negative suction pressure or the vacuum pressure. It utilizes the principle of specific gravities for measuring the suction pressure. This type of manometer generally has a liquid whose specific gravity is greater than that of the fluid whose suction pressure is to be measured. Now we will see the use of a manometer. A manometer is used in the maintenance of heating, ventilation and air conditioning systems. Manometers are used in the construction of bridges and in installation of swimming pools. Piezometers, that is a type of a manometer, is used to measure the pressure in pipes where the liquid is in motion. Manometers are used in medical applications like measurement of blood pressure and in physiotherapy as well. Now we will learn in detail about the U-tube manometer and we will see how to measure the gauge pressure. So U-tube manometer is basically U-shaped as you can see in this diagram with one end connected to a gauge point and another end which is open to the atmosphere. To measure the larger positive or negative pressures, the U-tube portion of the U-tube manometer is generally filled with a liquid of specific gravity greater than that of the fluid for which the pressure is to be measured, and this fluid is generally taken as mercury. Now, this line is known as the datum line. This is the lighter liquid and this is the heavier liquid. Now, the height above this datum line till the center of this pipe, this height will be called as H1, and the height of this heavier liquid above the datum line, it will be called as H2. Now as this is the lighter liquid, so the specific gravity of this lighter liquid will be termed as S1, and this one is the heavier liquid, so the specific gravity for this manometric liquid or the heavier liquid will be called as S2. Now for the measurement of the vacuum pressure, we will again consider a U-tube manometer with one end connected to a gauge point and another end open to atmosphere. So again in the similar way, this U-tube manometer also contains two types of liquid, that is one is a lighter liquid and another is a heavier liquid, and this liquid is having a greater specific gravity as compared to that of this lighter liquid, and this heavier liquid is generally considered as mercury. So the specific gravity of this lighter liquid will be called as S1 and the specific gravity for this heavier liquid or the manometric liquid will be termed as S2. Now this line is called as the datum line as told earlier in this case. So the height of the lighter liquid will be called as H1 and the height of the heavier liquid will be called as H2. So for both of these cases, that is for the measurement of gauge pressure and vacuum pressure for these lighter liquids, gamma 1 will be the specific weight of these lighter liquids in both the cases, and for this heavier liquid, that is for mercuries, generally mercury is taken as the heavier liquid. So for that, gamma 2 is the specific weight of heavier liquid in both of these cases. Now we will consider a point A in this U-tube manometer, and P is the pressure at the point A which is to be measured in both the cases. Now we will learn about the measurement of gauge pressure. So right in front of you is the U-tube manometer, and this part is known as the left column of the U-tube manometer, and this portion of the U-tube manometer is the right column of the U-tube manometer. Now the pressure in the left column of the U-tube manometer above this datum line will be equal to pressure in the right column of the U-tube manometer above this datum line. Now pressure in the left column is equals to P, that is the pressure at this point A which is to be measured, plus the pressure of the lighter liquid which is in the left part of this column. So that is equals to gamma 1, that is the specific weight of this lighter liquid, multiplied by this height, that is h1. So the pressure in the left column will be equals to P plus gamma 1 into h1. And on the right hand side you can see this heavier liquid is there. So the pressure on the righter column equals to h2, that is this height, multiplied by the specific weight of this heavier liquid or the manometric liquid, that is gamma 2. Now our equation will look like P plus gamma 1 into h1 equals to gamma 2 into h2. So this one is the pressure in the left column and gamma 2 h2 is the pressure in this right column. Now what we will do, we will just transfer gamma 1 h1 to the right hand side of this equation. So this plus sign will become minus on the right hand side. So P will be equals to gamma 2 h2 minus gamma 1 h1. Now we will learn the measurement of vacuum pressure. So right in front of you is the U-tube manometer, and here also you can see this is the left column of the U-tube manometer and this portion is the right column of the U-tube manometer. So here also we will equate the pressure in the left column of the U-tube manometer to that of the right column of the U-tube manometer above this datum line. So the pressure in the left column above this datum line will be equal to pressure in the right column above this datum line. Now my dear students, you can see that on this left column of the U-tube manometer there is a lighter liquid, so pressure will be there for this lighter liquid as well as for this heavy liquid or the manometric liquid. So the pressure in this part will be equals to the pressure at the point A, which we have to measure, that is P, plus for this lighter liquid, that is gamma 1 into H1 plus gamma 2 into H2, that is for the manometric liquid, that is the heavier liquid. So our pressure equation for the left portion or the left column will be equal to P plus gamma 1 into H1 plus gamma 2 into H2. Now in the right column, here you can see that no liquid is there, no fluid is there in this part. So here the pressure will be nothing but 0. So the equation will now look like P plus gamma 1 into H1 plus gamma 2 into H2 equals to 0. So this is the pressure in the left column of the U-tube manometer above the datum line, and this one is the pressure in the right column above the datum line. Here no fluid is there, that is why it is equals to 0. Now what we will do, we will just transfer gamma 1 H1 and gamma 2 H2 on the right hand side of this equation. So plus sign will become minus. So our equation will look like P equals to minus gamma 1 H1 minus gamma 2 H2. Now what will we do? We will just take minus sign common. So it will now look like P equals to minus gamma 1 H1 plus gamma 2 H2. As we have taken the minus sign common, so this one has become plus. So that's all for today. Please share this video with your friends and thank you all for watching this video.